Welcome to the second part of the course. Up to this point, we have built the fundamental concepts needed to understand the simulation methodology. What we have learned so far: basic concepts of Monte Carlo simulation and probability distributions. The three key components of the project model: tasks, costs, and risks. Now, our goal is to apply this methodology to assess how to meet project objectives, ensuring that it is completed on time and within budget. In this section, we will go step by step through solving the example model. So we have an initial deterministic evaluation. We will begin in cell B7 of the parameters sheet by setting up a deterministic model. What is a deterministic model? A deterministic model is one that does not incorporate randomness in its calculations or results. This means that it always produces the same result if the input data remains the same. There's no variability in the parameters. Probability distributions are not used. Multiple scenarios are not generated because no uncertainty is considered. For example, a project with a deterministic model, let's assume that the project starts on March 1st, 2026. This is on cell D2 in the tasks sheet. The estimated results without uncertainty: completion date, July 25th, 2026. Cell E2. Project duration, 146 days. Cell F1. Now we go to estimated costs. The fixed cost is in cell G1, $12,000. Variable costs, $11,000 on cell N1. Total project cost, $23,000 on cell O1. Now, important, this model, we have not yet introduced variability in durations and cost estimates. Now, how do we record deterministic values? Let's enter the following values in the parameters sheet. C5, deterministic completion date, July 25th, 2026. C6, deterministic total cost, $23,000. As we progress with new exercises, we will compare this deterministic scenario with more complex results based on simulation. One major limitation of the deterministic model is that it does not allow for scenario evaluation or probability calculation. To address this limitation, we will explore two different approaches. The approach one is the traditional scenario analysis. Scenario analysis is a technique where a limited number of predefined scenarios are evaluated. The three most common scenarios are the optimistic, the best possible conditions, the most likely, the base estimate, and the pessimistic, worst possible conditions. Problems with traditional scenario analysis: it only considers three specific scenarios, ignoring many other possible combinations. It does not capture all project uncertainties. It does not allow for probability calculations to determine the likelihood of each outcome. Approach 2, Monte Carlo simulation, the more robust alternative. Monte Carlo simulation is a more advanced methodology that evaluates thousands of possible scenarios by using probability distributions and computational power. Key advantages of Monte Carlo simulation over traditional scenario analysis: it evaluates multiple combinations of uncertainty rather than just three scenarios. It uses probability distributions instead of fixed values. It captures the real variability of the problem. It allows for probability calculations such as the likelihood of exceeding a cost or a deadline. What will we do next? In the upcoming exercises, we will apply Monte Carlo simulation to calculate probabilistic reserves and assess the impact of uncertainty on project outcomes. Why is this change in approach important? The deterministic model is limited. It does not account for uncertainty. The traditional scenario analysis is useful but incomplete. It only evaluates a few scenarios. Monte Carlo simulation is the best option. It allows for a more complete assessment of risk and uncertainty.